So this is our Honors Chemistry section 10.3 lesson video part 2. So in part 1 we talked about percent composition, and so in part 2 we're going to focus on calculating the empirical formula. But before we calculate it, we need to talk about what that even means. So there are two different types of formulas we'll talk about in this chapter. There's the molecular formula and the empirical formula. So the molecular formula is the actual formula for a molecular compound. It contains the actual number and types of each atom. The empirical formula, on the other hand, is the lowest whole number ratio of atoms in a molecular compound. So for example, glucose is C6H12O6. This is the molecular formula. One molecule of glucose actually has 6 carbons, 12 hydrogens, and 6 oxygens. However, I can reduce these subscripts to a lower ratio, and I can divide each of them by 6. So then it becomes CH2O. This is the empirical formula. A molecule of glucose does not just have 1 carbon, 2 hydrogens, and 1 oxygen. This is just the lowest ratio of the molecular formula. Okay, so here's some more examples, like P4O10 can reduce to P2O5. Now, not everything can reduce. Like H2O, it can't reduce, so its molecular and empirical formula are the same. N2O4 can reduce to NO2. C10H22 can reduce to C5H11, because of course they're both divisible by 2. C6H18O3, they can all be divided by 3, it reduces to C2H6O. And then the last one, C5H12O, it can't be reduced, so its empirical formula is just still C5H12O. So the important thing is, if I give you a molecular formula and ask for the empirical formula, if it can't be reduced, a lot of y'all tend to leave it blank. Well, if you leave it blank, then I mark it wrong, because I assume you have no idea what you're doing. It's just the same formula. Like H2O is the empirical formula. It's not like it doesn't have one. A lot of you think if you can't reduce, it must not have an empirical formula. It just means the molecular formula and the empirical formula are the same thing. So like I just said, sometimes the empirical formula is the same as the molecular formula. For example, H2O, I know you probably can't see the O because of the snowflake, but there's an O here. Alright, so let's figure out how do we calculate the empirical formula. So there's 3 steps, there's sometimes 4. We'll talk about the 4th step in a second. I'll put a star because we'll get to the 4th step here in a minute. So your first step is change percent to grams. Then your second step is convert grams to moles. And so in case you have forgotten how to do that, remember 1 mole equals molar mass. So we're going to convert from grams to moles. And then our 3rd step is divide each number by the smallest answer. So divide by the smallest. Now the first time you watch me do one of these, it's super confusing and you feel like, oh my gosh, how am I ever going to learn this? But then once you see it the 2nd time and then the 3rd time, you realize it's just a pattern. I'm just following the steps. Alright, so it says calculate the empirical formula for a compound that is 67.6% Hg, 10.8% S, and 21.6% O. So y'all, we're looking for a formula. That means I don't want a number answer like 226 grams. I want a formula. So what I mean by that is I know it has mercury, I know it has sulfur, I know it has oxygen. What we're doing is we're looking for the subscripts. Those are the numbers I'm trying to figure out. So Hg what? S what? O what? You know, is there a 2 here? Is there a 7 here? We're looking for the subscripts. Alright, so the first step is change percent to grams. This is the easiest step because what we do is we assume there's 100 grams total. And so if that's the case, then 67.6 grams really is mercury. So all I have to do is assume I have 100 total, and then my percentages can just turn into grams. So step 1 is the easiest. Alright, so 10.8% would be 10.8 grams of sulfur, and then 21.6% for oxygen would turn into grams. So first step, super easy. Second step, I have to convert from grams to moles using the molar mass. Alright, so this is where I need to use the periodic table. Alright, so I'm working with mercury, which is Hg. Its mass is about 200.59, so I'll round that to 201 grams per mole. So 1 mole is 201 grams. I'm not going to write all this out. We've got to learn to start doing some of this in our mind. Alright, so I follow the golden rule. Grams is going to go on bottom. For mercury, it's about 201 grams in 1 mole. once I divide, let me get on the right page. Once I divide, I get 0.34 moles of mercury. All right, so then I do the same thing for S and O. So for S, its mass is 32 grams in 1 mole. So since grams is on top, I put the 32 grams on bottom, the 1 mole on top. And again, y'all, we're just pulling the masses from the periodic table. It's the bottom number on the periodic table, and we're rounding it to a whole number. So I do 10.8 divided by 32, and so for S, I get 0.34 moles of S, or sulfur. So I do it for oxygen. So oxygen, 16 grams per mole. So I follow my golden rule. So 16 grams goes on bottom, 1 mole goes on top. And so once I divide, I get 1.35 moles of oxygen. Now, technically, these are supposed to be the subscripts. But obviously, it doesn't make any sense to have a decimal as a subscript. Like, I can't have Hg 0.34, S 0.34, O 1.35. But the thing is, the ratio is correct. Now, a lot of you just try to round. Like, for some reason, y'all will just round those to ones, even though 0.34 technically rounds down to 0. So a lot of you, you'll round both of these to ones and either round that to a 1 or a 2. I don't know. But either way, that's not what you do. You got to follow step 3. Step 3 is divide by the smallest. The reason we do this is we're going to make the assumption, that's why there's a step 4 in a minute. We're going to make the assumption that the lowest number is actually just supposed to have a subscript of 1. And so, of course, if you divide something by itself, it will become 1. Because the thing is, the ratio is already there. So if I change one number, I have to change all the numbers in the same way. So I find my smallest, which is, of course, 0.34. And I divide all of them by the smallest. So again, what this is doing is it's keeping the ratio the same because I'm dividing all of them by the same number. But I should get nice whole numbers that could actually be considered subscripts. So when I do that, I do get 1 for Hg, I get 1 for S, and I get 4 for O. So see, these are nice whole numbers. And y'all, at this step, you should get pretty close to whole numbers. It might not be perfect, because again, we're doing rounding along the way, but it should be very, very close. And so these would be my subscripts. So my formula would be Hg, because I don't need to write a 1, S, because again, a 1's understood, O, 4. And so this would be my empirical formula for this compound. All right, so again, the first time you see it, everybody's just like, oh my gosh, what's happening? But I promise, if you'll just watch another time, you'll realize it's just a pattern. We're just following our 3 steps. Okay, so we'll look at a couple more that only involve the 3 steps, and then we'll focus on, okay, well, what's this step 4? All right, so let's look at the top one together. So it says, calculate the empirical formula for the following compound that is 94.1% oxygen and 5.9% hydrogen. Now, of course, if you feel comfortable, you can pause the video and try this on your own. Otherwise, we'll look at it together. So I've been given my percentages. My first step is change percent to grams. So remember, what I'm going to do is I'm going to assume that I have 100 grams to start with, and so I'm just going to change my percentage to grams. So here, I'll start right here. So I have 94.1 grams of oxygen. Ooh, sorry, my G kind of looks weird. And 5.9 grams of hydrogen. All right, so step 2 is, of course, I need to then change grams to moles using the molar mass. All right, so for oxygen, I look at the periodic table. Oxygen is 16 grams per mole. So since grams is on top, I'm going to do my 16 grams on bottom and my 1 mole on top. Just like that. So once I divide for oxygen, I end up getting 5.88 moles of oxygen. All right, next I do hydrogen. So hydrogen has a mass of 1 gram per mole, a molar mass. So because grams is on top, I'm going to put my 1 gram on bottom and my 1 mole on top. And so, of course, I get 5.9 moles for hydrogen. So my next step, of course, is to divide by the smallest, because right now you might be tempted to say, oh, because remember, we're trying to figure out the subscripts. You might be tempted to say, oh, it's O6H6. Okay, but we need to divide by the smallest. So the smallest is 5.88. And so when we divide, we're going to get 1 for oxygen, and we're going to get 1 for hydrogen. So since they're both 1, no subscripts necessary. It's just OH, just like that. Alright, so let's move on to the next one. Hopefully you got that one right if you tried it on your own. Now our next one is slightly different because notice I didn't start you out with percentages. Alright, so it says a 5.325 gram of methyl benzoate, a compound used in the manufacturing of perfumes, contains 3.758 grams of carbon, 0.316 grams of hydrogen, and 1.251 grams of oxygen. What is the empirical formula of the substance? Alright, so because I didn't leave myself a whole lot of room, I'm actually going to erase this and work this one out up here. The question was so long that... Alright, so here, we'll just do this one right up here. Alright, so step 1 is change percent to grams. But notice here, I went ahead and gave you the grams. Like, we're not assuming 100 grams. I told you this is how many grams we're starting with, and this is the breakdown. So really, you can just skip step 1. Okay, I can clearly see it has carbon, it has hydrogen, and it has oxygen. So I'm looking for C something, H something, whoop, I almost put 6 for some reason, O something. And so I'm trying to figure out those subscripts. So like I said, because it's already in grams, I can just skip step 1. Alright, so I'm going to start with my carbon. So I have 3.758 grams of carbon. So my second step is to get it into moles using molar mass. So carbon is 12 grams per mole. So because grams is on top, I'm going to put the 12 grams on bottom, the 1 mole on top. So once I solved for that, I ended up getting 0.313 moles for carbon. All right, next I have 0.316 grams of hydrogen. So I need to convert that to moles using molar mass. The hydrogen is 1 gram per mole. So since grams is on top, I put my 1 gram hydrogen on bottom. That equals 1 mole. My grams cancel, and so of course I get 0.316 moles of hydrogen. All right, and then last one, I have oxygen, 1.251 grams. So again, I'm going to change it to moles using molar mass. So for oxygen, it's about 16 on the periodic table, 16 grams per mole. So because grams is on top, I'm going to put my 16 grams on bottom. That equals 1 mole. Now, if you hadn't noticed, you need to get really good between changing grams and moles, just for many chapters to come. All right, so once I divide, for oxygen, I got 0.078 moles of oxygen. So again, these aren't good subscripts. They're all decimals, so I need to divide by the smallest. So if we look, my smallest is 0.313. So I'm going to divide all of them by 0.313. So of course for carbon, that gives me 1 mole for carbon. For hydrogen, that gives me 1 mole for hydrogen. And for oxygen, it gives me, oh, whoops, I just totally divided by the wrong one. Oh my gosh, okay, well that was ridiculous. I'm sorry, I just picked the wrong one. Redo. I was wondering when I looked down all of a sudden, I was like, these aren't the right numbers. Okay, I'm so sorry, y'all. I didn't even pick the right one in this case. So that brings me to my next point. Make sure that when you divide by the smallest, you actually pick the smallest. Sorry, I didn't notice this 0 there, and in my mind, I thought it was 0.78. All right, so sorry about that. Okay, so our smallest number is 0.078. So I'm going to divide each one by 0.078. Boy, if I was better at editing videos, I would take this out. That's an embarrassment, but oh well, it's already happened. And I'm not great at editing. It takes too long. All right, so once I divide this, I'm going to get 4 moles of carbon. And then once I divide this, I get 4 moles of hydrogen. And then for this one, I'm of course going to get 1 mole. All right, so now I have nice whole numbers, and so those are my subscripts. So my formula will actually end up being C4H4O, because of course we don't need the 1. However, if you write the 1, I'm not going to mark it wrong. I just hate it. It's understood, so don't write the 1. Okay, so again, y'all, once you get to step 3, please, unlike what I just did, make sure you actually divide by the smallest. And instead, I divided by the smaller of these two. I don't know what's going on. I'm making a lot of lesson videos today, so I'm not going to lie, it's a struggle. All right, so let's move on to this 4th step that I have yet to tell you about. Okay, so why is there a fourth step? Aren't these problems long enough? Yes, they are, but there is sometimes a fourth step. So after step 3, normally we get nice whole numbers that make for perfect subscripts. However, sometimes we're going to get a number that ends in 0.5, indicating there's a half, or like 0.3, indicating there's a third. You cannot round these numbers. What's happening is, when we divide by the smallest, we assume the lowest subscript is going to be a 1. However, not everything has a subscript that has a 1. Like its empirical formula, it could be a 2 and a 5. It could be, a 6 and a 7. And so in that case, you'll end up with a fraction. Again, the ratio is still correct. So you fix it by just getting rid of the fraction. So how do you get rid of a half? You multiply all the answers by 2, not just the one that has the 0.5. If you get a 0.33, that implies there's a third. So to get rid of a third, you multiply all the answers by 3. All right, so let's look at a couple of these. So it says, a compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. What is the empirical formula of the compound? All right, so I can see I clearly have nitrogen and I clearly have oxygen. So it's going to be in something, O something. So my first step is change percent to grams. So we're going to follow the same steps. So it gets 25.9 grams of nitrogen and 74.1 grams of oxygen. Step 2 is to convert to moles using the molar mass. So nitrogen, of course, on the periodic table is 14 grams per mole. So I follow my golden rule and I put my 14 grams on bottom and my 1 mole on top. And so once I divide that, I end up getting, let me get to the right spot, 1.85 moles of nitrogen. All right, and then for oxygen, it's 16 on the periodic table, 16 grams per mole. So I follow my golden rule and put the 16 grams on bottom and the 1 mole on top. My grams cancel. And once I divide that, I get 4.63 moles of oxygen. All right. Now, the problem is, once we talk about step 4, which, by the way, remember, if you get something that ends in a 0.5, you multiply all of them by 2. If you get something that ends in like a 0.3, you multiply all by 3. Once I tell you this step, a lot of you decide to try to skip over step 3. And you're like, wait a minute, this isn't a 0.5 or a 0.3. What do I do? Well, you're not to step 4 yet. You still need to go through the divide by the smallest step. Okay, so let me make sure I pick the correct smallest one this time. So the smallest one is 1.85. So I'm going to divide both by 1.85. Gosh, I'm never going to live that down. Can't believe I did that on the previous question. All right, so of course this ends up being 1. And then this, when I divide, ends up being 2.5. Now I know that you want to round that up to 3. Everybody does. Who doesn't want to round 2.5 up to 3? But you can't. You have to fix it by multiplying by 2. But because the ratio is correct, if I multiply this one by 2, I also multiply the other one by 2. Like I can't just change one of them. So even though this one didn't have the 0.5, I still have to multiply it by 2. So I get 2 for nitrogen, and I get 5 for oxygen. So my formula ends up being N2O5. And so that's how step 4 works. And so sometimes you need step 4, sometimes you don't. If you end up with nice whole numbers right here, you don't need step 4. The problem is when you end up with a fraction left over. All right, so let's look at another one. All right, so maybe pause the video and you try this one on your own. I'll go ahead and tell you, hint, hint, you are going to need step 4. Okay, now I'll assume you've done that. Let's look at it together. So it says determine the empirical formula for this compound. So I can see it has C, H, and O. So again, I'm going to have C something, H something, O something. I need to figure out what those subscripts are. So I gave you percentages. So our first step is we're going to assume there's 100 grams total, and I'm going to change my percent to grams. So I have 50.7 grams of carbon. I have 4.2 grams of hydrogen and 45.1 grams of oxygen. All right, so step 2 is to change to moles using the molar mass. So remember, molar masses are just the bottom numbers on the periodic table. So carbon is 12 grams per mole. So I'm going to follow the golden rule and put my 12 grams on bottom. my 1 mole on top, and of course I do that because I want grams to cancel. So once I divide that, I get 4.23 moles per carbon. Alright, so next I go to hydrogen. So hydrogen is 1 gram per mole. So I'll follow my golden rule and I'll put the 1 gram on bottom, the 1 mole on top. And so I get 4.2 moles for hydrogen. Alright, and then last I do oxygen. So oxygen is 16 grams per mole. So since I want grams to cancel out, I put the 16 grams on bottom, the 1 mole on top. Grams cancel, and when I divide for this, I get 2.82 moles oxygen. So again, y'all, I'm not going to decide at this point yet if I need step 4. I still have to do step 3. So I need to divide by the smallest, which clearly I just showed you a few slides ago that I apparently have trouble picking the smallest all of a sudden. Okay, so the smallest, of course, is the 2.82. So I'm going to divide each of them by the 2.82. So when I do that, when I divide for carbon, I get 1.5. And so again, y'all, I know you want to round that to 2, but you can't. When I divide this one, I also get 1.5. And then when I divide my bottom one, I of course get 1. So again, even though only these two have the 0.5s, the ratio is already correct. So to fix the 0.5, I multiply all of them by 2. So I'm going to multiply this by 2 and get 3. I'm going to multiply this by 2 and get 3. And I'm going to multiply this by 2 and get 2. So, now, whoops, sorry, this should be an H. So, now I know my subscripts. So my empirical formula will be C3H3O2. Just like that. Alright, so for empirical formula, the important thing is make sure you know your steps. Okay, first step, we're going to assume 100%. 100 grams total, so we can change percent to grams, unless, of course, they go ahead and give you grams, and then you can just use that. Second step, I convert from grams to moles using molar mass off the periodic table. Again, y'all get super good at going between grams and moles. We're going to have to do that a lot. And then the third step is I assume the lowest subscript is going to be a 1. So I divide all of them by the smallest, which clearly we can see you can struggle with that sometimes, like I just did a minute ago. Alright, and then if you get nice whole numbers, those are your subscripts. If not, you may need to fix a fraction by using step 4. Okay, but really, y'all, it's just about getting these steps down. And actually, it makes it easier to use the steps if you understand why we're doing them. Like how I said, we assume you have 100 grams total. We assume the lowest subscript is 1. So like knowing why we're doing things helps it make more sense that we're doing it.